Oh, thank you. Thank you for giving me the opportunity to present some of my work today. So my research interests lie in the area of reproductive endocrinology and andrology, including the role of endocrine system in unsuccessful aging and frailty. And this is what I'm going to talk about today and present some of my research findings to date. So what is frailty? It's a term which has been very commonly used in the last few years, and I'm sure you've all come across that. But sometimes it's used incorrectly, really, and it's often very misunderstood. It's commonly used almost interchangeably with comorbidity, with aging, with disability, but it's quite frankly very different from all those states. And frailty is really a state that is characterized by the loss of biological reserves across multiple organ systems, failure of homeostatic mechanisms, and vulnerability to physiological decompensation, even after minor stressor. So therefore, frailty is associated with adverse health outcomes such as disability, falls, hospitalization, and death. And even though frailty is closely linked with aging, it's not really an obligatory part of it. And many people reach advanced ages without becoming frail. As you know, normal aging is really a result of accumulation of damage across multiple systems at the cellular and molecular level, and that the results in a decline in the functioning of various physiological systems. So in frailty, similar happens, but this process of decline is accelerated. And that's why we often refer to frailty as accelerated aging or unsuccessful aging. And the onset of frailty typically occurs at the ages of 65 to 70, thereabouts, but of course younger people can become frail as well. And the process of unsuccessful aging is really a cascade of functional decline from independence or robustness through pre-frailty, frailty to disability, of course, in the absence of any intervention. And frailty is sometimes not obvious until some even minor stressor, such as minor illness or minor surgery, or let's say even introduction of a new medication, results in disproportionate changes in health, followed by prolonged recovery period, and frequently failure to return to the level of functioning from before the insult occurred. Now we know from the research that is available that frailty is most likely, or this aging and successful aging process is most likely not a one-way process. So it is potentially modifiable and at least partly reversible. And why is it so important? Because with raising life expectancy, frailty is increasingly recognized as an important healthcare issue and presents a challenge to healthcare systems worldwide. Recent meta-analysis reported that the incidence rates of frailty and pre-frailty were as high as 43 and 151 cases per 1,000 person years, respectively. And it's believed that at least 1 in 6 community-dwelling older people might have frailty already. And interestingly, incidence of frailty and pre-frailty is higher in women than in men. And this gender differences might be attributable to biological and socioeconomic factors, but nevertheless, women have been found to better tolerate frailty overall, as evidenced by lower mortality rates at any frailty level and age compared to men. And this concept of frailty is not really new. I mean, it first appeared in literature in the 1960s, but it wasn't until 2001 when the first operational definition of frailty was introduced by Linda Fried and colleagues. And this group described frailty as a continuous cycle of declining body energetics and physiological reserve. And central features in the process of development of frailty were really sarcopenia, loss of muscle mass and function, low energy levels and low activity levels. And Fried proposed a measure of frailty, which we call nowadays frailty phenotype, which is based on 5 physical criteria which commonly cluster in individuals with frailty, such as weakness, slowness, low levels of physical activity, exhaustion or fatigue, and weight loss as a proxy for sarcopenia. And individuals with 3 or more of these criteria are classed as frail. Those with 1 or 2 are considered pre-frail, and those with none, of course, robust or non-frail. And this frailty phenotype has been validated in many studies, and it's predictive of adverse health outcomes such as falls, hospitalization, and death. And since then, really, there's been an increase in frailty-related research, particularly in the last few years, mainly investigating its natural history and etiology. But ultimately, the goal is not only to be able to identify those who have frailty or are at risk of frailty, but to facilitate the development of new prevention and treatment strategies. But to be able to do that, we need to know a little bit more about the pathophysiology of frailty and the mechanisms behind it. And currently, this is not very well understood. The development of frailty has been linked with abnormalities in metabolism, chronic inflammation, and even clotting abnormalities. But decline in muscle mass and muscle function, or broadly speaking, sarcopenia, appear to be central to the development of frailty. And of course, that results in decrease in activity level, lower resting metabolic rate, and lower energy expenditure. And since the anabolic hormones are one of the key factors that are responsible for muscle mass, muscle growth, and function, endocrine dysregulation has been proposed as one of the factors that might have a potential role in development of frailty. And this notion is further supported by clinical sequelae of various endocrinopathies, which share common features with those of frailty in both men and women. But it's not only the pathology within the endocrine system that attracted researchers' attention. Really, normal aging process and frailty share common features as well in relation to changes in body composition, muscle strength, physical function. And all these occur in parallel and together with gradual decline in circulating levels of anabolic hormones. And we know from large epidemiological studies that, for example, in a man, total testosterone levels decline after the age of 40 by about 1% a year. And similar situation occurs for another hormone, DHES, dihydroepiandrosterone sulfate, which again, in both men and women, declines after the age of 30, 40. And this is also true for insulin growth factor 1, IGF-1, which is a proxy for growth hormone action. So these observations have led to an increased interest in the role of these declining anabolic hormone levels in the aging process and the development of frailty. And there have been a small number of mainly cross-sectional studies that investigated these associations. But the data are largely conflicted and very limited. Prospective data, again, largely lacking. So I decided to investigate these associations further in a longitudinal study design. And my main objectives were to investigate whether the baseline levels of anabolic hormones are related to the development or can predict the development of frailty in aging men, and also whether those so-called age-related declines in androgen levels are actually related to contemporaneous changes in frailty and physical function. And I was fortunate to have had an opportunity to work on the European Male Aging Study, which is a large multi-center prospective cohort study designed to investigate health outcomes in aging men in association with variation in hormone levels. And the study was funded by EU, and it included nearly 3,400 community-dwelling men aged 40 to 80 from 8 European countries. And these men underwent very detailed assessment of their health in general, physical function, their cognitive function, body composition, and also had fasting blood sample taken for measurement of variety of hormones and biomarkers. And after a median period of 4.3 years, they were recontacted again, and the data were collected in the same manner as at baseline. So first of all, I was interested to assess the frailty status of these men at both phases of the study. And for that reason, I used the two commonly used but yet quite different approaches to characterize frailty. The first one is the frailty phenotype, which I mentioned earlier, which evaluates the physical aspects of frailty and focuses on 5 key characteristics, such as slowness, sarcopenia, exhaustion, low activity, and weakness. And again, as previously mentioned, those men who had at least 3 of these criteria, they were considered frail. Those with 1 or 2 criteria were pre-frail. Those with none were robust. And secondly, I assessed frailty by so-called frailty index, which comprises 39 health deficits, and those include physical as well as cognitive impairments, physical signs and symptoms, and comorbidities which are linked to frailty. And frailty index was calculated as the number of deficits present in an individual divided by total number of deficits considered. And it was presented on a scale from 0 to 1, with higher values indicating greater frailty levels, as you can see in this table. So our cohort for this particular analysis included nearly 2,500 men with a mean age of 59 years and BMI of 28. 6% of the population had diabetes, 1/3 had cardiovascular disease, and 21% history of depression. At baseline, 23.7% of the study sample were either pre-frail or frail by frailty phenotype, and this proportion increased to 33% at follow-up. The median frailty index at baseline was 0.09, and that again, after 4 years, increased to 0.1, so increased by 10%. And when I compared the men who did not experience any change in their frailty status over this 4-year period, men whose frailty status deteriorated, worsened over 4 years, they were older, they had a lower BMI, they were less active physically, they had higher prevalence of diabetes and cardiovascular disease. And their levels of anabolic hormones such as DHEAS or IGF-1 and its binding globulin, they were lower than those whose frailty status has not changed. And conversely, when I looked at those men whose frailty status improved after 4 years compared to those who remained either pre-frail or frail, these men were younger, and they were more active physically and had lower prevalence of cardiovascular disease. And their hormone levels, the anabolic hormone levels, were numerically higher than those who remained frail or pre-frail. However, the differences were not statistically significant for most of them except for the DHEAS. And these tables represent the results of the regression analysis, statistical analysis, looking at associations between the hormone levels and the 4-year change in frailty. And as you can see here in fully adjusted models, so models adjusted for age, center, BMI, higher levels of IGF-1 and its binding protein, as well as vitamin D, were all associated with lower risk of worsening frailty at 4 years. And that was true for both frailty index and frailty phenotype. Also, what I found is that the higher level of DHEAS was associated with lower risk of worsening frailty by frailty phenotype, but only in men older than 70 years of age, not in younger ones. And in fully adjusted models, I found that the higher levels of vitamin D were associated with increased risk or likelihood of improving frailty at 4 years. And now when we look at testosterone and associated hormones, we can see that higher levels of total testosterone, free testosterone, which is the biologically active fraction of testosterone, as well as the hydrotestosterone, which is a metabolite of testosterone, they're all associated with low risk of worsening frailty at follow-up. But after multiple adjustments, only free testosterone remains significantly associated with low risk of worsening frailty. When I did the same analysis for frailty phenotype, again, free testosterone appeared to, higher free testosterone appeared to be protective of worsening frailty. However, the associations were deemed statistically non-significant after adjusting for age. And interestingly, higher estradiol level was associated with lower likelihood of improving frailty by frailty phenotype at 4 years. So in summary, what I found so far is that the higher levels of free testosterone, vitamin D, and insulin growth factor 1 and its binding protein were all associated with lower risk of worsening frailty status at 4 years. It's worth noting, though, that the IGF-1 was no longer a significant predictor of frailty after adjusting for its binding protein, which again is in keeping with mediating effect of that protein. And also high DHEAS level was associated with low risk of worsening frailty phenotype, but only in men older than 70 years of age. So moving on to the second part of my hypothesis, I investigated the prospective declines in androgen levels in relation to parallel changes in frailty status and in physical function. And as outcomes, I evaluated the change, 4-year change in a number of physical endpoints, such as gait speed, which was measured by timed 50-meter walk test, lower limb muscle strength measured by timed 5 sit-to-stand test, self-perceived physical activity levels, physical quality of life derived from quality of life questionnaire SF36, and also 4-year change in frailty phenotype and frailty index. And my predictors were 4-year changes in total and free testosterone as well as DHEAS. So the study population for this analysis included nearly 2,300 men, who of course at baseline had a mean age of 58, then at follow-up 63 on average. The prevalence of cardiovascular disease in this group increased from 33 to 44% over a 4-year period, and the same happened for diabetes, so this increased from 6 to 8%. And the hormone levels, as expected, have declined. So total testosterone, free testosterone, DHEAS have declined over time. But it's worth noting that those levels are still and were still within normal reference range for the age group. And this series of slides show the regression models, the regression model relationships between age-related changes in androgen levels and changes in physical outcomes. So in the top panel, you can see that a decline in total testosterone and free testosterone was associated with the increased time taken to walk 15 meters. And this remains significant after adjusting for multiple covariates. And the bottom panel here, you can see that 4-year decline in the levels of total testosterone and free testosterone were again associated with time, with a prolongation of time taken to perform 5 chair stands. And that again was significant after multiple adjustment. And I've also observed that decline in total testosterone, free testosterone, and DHEAS were all associated with worsening physical quality of life, as assessed by a quality of life questionnaire. But these associations remain significant only for total testosterone, free testosterone after multiple adjustments. And I've not observed any association of declining levels of these hormones with self-perceived physical activity levels. And when we look at the changes in frailty over a 4-year period, we can see again that all these hormones, the decline in all these anabolic hormones, were associated with worsening of frailty phenotype at 4 years, but after multiple adjustment, the association remains significant only for free testosterone and DHEAS. And for frailty index, again, only declines in free testosterone levels were associated with worsening in frailty index at 4 years. So in summary, I've demonstrated that decline in total and free testosterone levels as well as DHEAS was significantly associated with deterioration in objective and subjective measures of physical function and worsening frailty. And of course, I acknowledge that this is observational data from cohort studies, so I cannot prove causality, but it would seem plausible that decline in these hormones are contributing in some way to worsening physical function and frailty. However, important note here that the size effect of these associations was small. And so what it means is that decline in these hormones during the follow-up period would potentially only account for about 1% of decline in physical function and frailty. So whereas it might be significant in statistical terms, in clinical terms, it's a very small significance. And this would be in keeping with the data that we've seen from testosterone interventional trials that yielded small improvements in physical function with testosterone placement in older men. So earlier on, I mentioned that the link between frailty and hormone and anabolic hormones is thought to be at the level of muscle. And anabolic hormones are considered key factors in maintaining muscle fiber cross-sectional area through mainly the effects on protein, muscle protein turnover, but also they promote myogenesis. But what's not been previously explored in detail is the role of these hormones in broader neuromuscular system, including motor unit structure and function, during both frailty and frailty. So what is motor unit? So motor unit includes a motor neuron and all the skeletal muscles, muscle fibers that it innervates. So activation of individual motor units during movements ensures that there is a precise matching of muscle forces to meet the task requirement. And with age, we observe that the number of motor units decline, and that's largely due to the losses of motor neurons, which of course limits then the ability of the central nervous system to control voluntary movements precisely. So by way of compensation, the neighboring motor neurons, as you can see here, reinnervate those muscle fibers that lost their nervous supply. And this process is called motor unit remodeling, reinnervation, and that results in motor units, in fewer motor units, of course, but they are larger than the original motor units that we've observed. Of course, if this process fails, then we're faced with atrophy of the muscle. And the underlying regulation of motor unit remodeling in normal aging with sarcopenia or frailty really remains poorly understood, but may be associated with some hormonal changes that I've previously described. So my aim was to determine if the associations between anabolic hormones and motor unit characteristics are present at all in men from general population, and whether they vary across health and frailty. So for that purpose, an observational cohort study called Motor Unit Remodeling Study was set up. It was funded by Medical Research Council UK and included 114 community-dwelling men aged 65 to 90 who were recruited from Greater Manchester area in the UK, and they had thorough assessment of the physical function, the body composition, and frailty status. They also underwent electromyography of a number of muscles, including vastus lateralis, so the quadricep muscle, and also had a detailed endocrine biochemical profiling done. So the main characteristics of the motor units that I was interested in was CMAP, which is compound muscle action potential, and MAP, motor unit potential. And CMAP represents the sum of electrophysiological signals from all motor units detectable by the recording electrode. And this is used in clinical practice for tracking disease progression in various myopathies, neuropathies, or motor neuron disease, for example. And the CMAP was recorded in the quadricep muscle at the motor point by the surface EMG electrode after stimulation of femoral nerve. And motor unit potential, on the other hand, it represents a sum of electrophysiological signals from a single motor unit. And these signals were recorded after inserting intramuscular needle electrode into the quadricep muscle and recording those potentials. So the study sample for the purpose of this analysis included 98 men with a mean age of 73 years and mean BMI of 26. 11% of them had diabetes, 19% had cardiovascular disease, and as you can see here, their median frailty index was 0.1. 18% of them were frail by frailty phenotype. 45% were considered pre-frail. And this table represents the results of statistical analysis looking at the associations between the hormone levels and the electromyography parameters, so the CMAP and MAP. And as you can see here, the higher levels of total testosterone and free testosterone were associated with larger or greater CMAP, which really reflects the fact that high testosterone levels are probably linked to greater muscle contractility. We've not observed significant associations of these hormones with motor unit potentials, except for vitamin D, which albeit in an unadjusted analysis, higher vitamin D level was associated with larger motor unit potential, which might imply that vitamin D might be linked to larger motor units, so it might have some role or indicate some role in remodeling process. When the sample was stratified by the frailty level, we've shown that the relationship between CMAP and free testosterone was much stronger in men who were frail as opposed to those who were pre-frail or robust. And the same applied for frailty index. So the relationship between free testosterone and CMAP was greater with increasing levels of frailty by frailty index. So these are novel human observations, and they're important for future clinical research and clinical care. It appears that the high levels of certain anabolic hormones may protect elderly men from worsening frailty and physical function that occurs with age. And it would seem that some of these actions might be exerted at the level of muscle, so they might play a role in the maintenance of neuromuscular function. But of course, these are observational studies, so the causal nature of these relationships needs to be further investigated. And that has to be done by the means of interventional trials, really, to see whether the hormonal manipulation aimed at improving muscle function and physical function can be of benefit, and to whom, really. Judging from the results that I've shown you, it appears that if any hormonal manipulation is of benefit, that probably will be to the frail. And last but not least, I would like to acknowledge all my collaborators, without whom this work would not be possible, particularly my mentors, Professors Martin Rutte, Fred Wu from Manchester, other principal investigators of EMAS from all over Europe and Canada, and my collaborators from the Muscle Physiology Lab from Manchester Metropolitan University. And thank you for your attention. I'm happy to answer any questions.